by Women Who Code Python. And Women Who Code Python's mission is under Women Who Code. And Women Who Code is a global not-for-profit dedicated to inspiring women to excel in technology careers and technology adjacent careers and technology support careers. So everything from coding to research to marketing, project management, etc. We have 4 main goals. We want to empower women with the skills needed for professional achievement, educate companies to better promote, retain, and hire talented women because we all rock, build a global community where networking and mentorship is valued, and develop role models and support this generation of engineers and technology workers. We do have a code of conduct. We are an inclusive community. We're dedicated to providing an empowering experience for everyone who participates in or supports our community. And that is regardless of any of the categories that you see there. And that does include preferred programming language, although we are really all about the Python, but that doesn't mean that if someone can help you with JavaScript that we're going to refuse to. We welcome everyone. Our events are intended to inspire women to excel in technology careers, and anyone who is there for that purpose is welcome. And we don't tolerate harassment. Our code of conduct applies to all of our events and all of our online communities, and you can read the full version and also look at or file an incident report at that URL that you see there. We are not the only online global community. There are actually 6 sponsored by Women Who Code. They include the 6 that you see here. Data science, pretty awesome, cloud, mobile, blockchain, front end, and of course, Python. And we always like to thank our sponsors because without them, this just would not exist. So our sponsors include McKinsey & Company, the Python Software Foundation, the Home Depot, Atlassian, and I thought there was another one on there, but there's not. Okay, so those 4. And welcome to ML Mondays. This is Math for ML Part 2. This is session 3, hosted by Yashika and Bethany and Liliana. And we just want to kind of go over what is this study group thing. We just want to remind people that we're trying to make this less about lecturing to you and more about encouraging you to get involved with this topic. We want it to be fun and we want to increase our knowledge together. We're not experts. We are curious just like you are. And we may have a few more resources under our belt or not, but we really are wanting to engage in this together. We want this to be a collaboration. We want to learn from each other. So that means asking questions, doing collaborative work, and catching me out if I make a mistake, catching Yashika out if we make a mistake, helping each other. So this is not where you listen to a complete presentation from an expert. So we aren't taking notes for these sessions or producing explicit slideshows, although we are doing a lot of Python notebooks. And we do have a repo for community code and notes and links to resources. And this is the second part of Math for ML, computer math for ML. And we want to strike back at that math panic with the power of code, because math can be an uphill battle for many of us. Despite fully understanding what's going on, it's still a lot of math. So we don't want you to panic or despair about that because Python can do the math for you. So once you orient yourself with the core ML concepts, you can let the scientific Python stack of libraries do the heavy lifting. And so what is that stack? It's the Python libraries we use when we deal with all the math and related visualizations and statistical distributions. And because each library has a dependency on others, they're stacked. So those include Python and IPython. So Python, of course, is whatever version of Python that you're running or whatever distribution that you happen to be running. Some of those include Anaconda, which is a very, very popular one, or Canopy, which used to be very popular, but it's a little bit dated at this point, or any number of flavors of Python. But it also includes this thing called IPython, which is an interactive Python shell, which kind of gives you better error messages and connects you better to like the command line. You can pass command line terminal commands through it, which is kind of cool. And then on top of that sits NumPy, NumPy provides support for matrices, which we all had a lot of fun with last week, and n-dimensional arrays, linear algebra, C, C++, and Fortran integration, and scientifically precise number types, which we'll probably come back to multiple times, but Python doesn't really represent numbers in a way that makes scientists feel all that comfortable because they're not precise to a specific decimal place. It tends to vary based on your hardware implementation, which just doesn't fly for a lot of scientific stuff. So the NumPy library actually goes in and pins or provides pinning for specific precision and specific number types. There's, I think, 16. We can provide a link to those. But that's so you know that every time you run a formula, you're going to get the answer that you want. So NumPy provides a lot of goodies. And then on top of that is SciPy and Matplotlib. SciPy is actually a distribution put out by the makers of Canopy. And they add in some symbolic math, which we don't use a whole lot of, but it is super convenient. And they package IPython and NumPy together. And then we have Matplotlib. Matplotlib provides graphs, visualization, and charting. And then we have Liliana's favorite, pandas. And that is a whole set of tools that you use to work with tabular data. So data that's labeled like an Excel file or a CSV, where you have this notion of labeled columns and labeled rows. And that actually depends on Matplotlib and NumPy for much of its functionality. Then we have scikit-learn. Scikit-learn is a machine learning library, a basic machine learning library, and it has tools for working with statistical distributions, random variables, like we went over last week, core ML algorithms that you then train to a specific purpose. It also has a lot of interesting sample data that you can play with. The IRIS data set is an infamous one, and the Titanic one, and there's a diabetes data set that come with the library so that you can kind of practice using its functions. So it's a great ML starter library. And then finally, we've got Jupyter, and you're all familiar with that from working with these notebooks. But Jupyter is actually a whole constellation of tools. And there's actually a newer part of it called the Jupyter Labs. And you can present and transport research, data, and code and package it together in a notebook. It's relatively platform independent, as long as somebody else has tools for reading a notebook or for running a notebook, then they can do that irrespective of what platform they're on. It supports multiple programming languages. This is something people don't commonly know. It's not just Python. Jupyter will support Go and JavaScript. And yes, you can do machine learning in those languages as well as Java and a bunch of other ones. And it's become basically the go-to standard for presenting data science and code in a reproducible fashion. So I'm going to stop talking now, and I'm going to go ahead and give it over to Yashika, who has put together an amazing notebook. And she's going to get you guys involved in having some fun with math and the scientific Python stack. All right, we do encourage you to go to the repo and to launch either a Colab session if you have a Google account or a Binder session if you don't, and kind of follow along with Yashika. We do have, these exercises are meant for you to kind of interact with and ask questions as you go along. So I don't know if we need to repaste I can repaste the link in there as Yashika gets started. Yeah, all you need for these notebooks is a browser. So let me just go ahead and put the repo back in there. So if you push the little arrow next to the notebooks button in this repo, you'll see links to all three, and we're going to go through the Maths for Machine Learning Part 2 in that repo.
Someone asked a question.
So 1 or 2 sentences on what machine learning is exactly. I've done some data analysis using pandas, NumPy, R, etc., but still not clear on how ML is different from data analysis. That is an excellent question, Don. Yashika, do you want to take that?
I think you can explain this better.
Okay. So the difference between machine learning and data analysis is that typically you're doing data analysis once you've cleaned up that data to see patterns in that data, whether that's a distribution or some sort of weighting, whether or not you're looking at the means or the averages, or you're doing a visualization. And that is actually part of machine learning, but that's like the pre-step. And then with machine learning, you take that data, the data that you know, and you actually develop an algorithm that you think describes not just that data, but data to that purpose. And you train that algorithm with the data, the training data, so that you can then predict outcomes based on data that you haven't seen before. So your data might be data like housing prices, and there are housing prices that are tied to how big the house is, how big the lot is, what part of town it's in, how many floors it has, whether or not it has a marble entryway, et cetera, et cetera. And you train probably a linear regression algorithm at that point on that data, so that when you get new houses, you can possibly predict the price. Oh, I'm looking at the chat. I only see ML for one. Where can I find the part 2 for today? You should be able to see the part 2 for today at that link. You're not seeing that, Karen?
Yeah, she needs to refresh, I think, because it was not showing up first.
You can find that in the same repo. Okay.
Oh, she found it. Good.
Okay, great. Yeah, so I mean, Don, to just expand a little on what I said, so I described linear regression, but there are other types of machine learning, but essentially what it is looking at data and developing a theory or a hypothesis about that data and what it says, and then developing a process by which you can predict an outcome based on data you haven't seen before. And that's what we call the learning part of it. All right. How are we doing, Yashika? You've got it up and running? Anyone, are you still having trouble seeing the repo? If so, I can provide a direct link to Colab if anyone is still having trouble. Awesome, okay. It seems everyone has found it. Yay! All right. Well, let's play with some of the mathematics for machine learning then.
Okay. So if you don't have any doubts, I'm going to start with today's session. Okay, so here we are alive totally after the last review, and the math was heavy indeed, but okay, we are alive. So today we are going to see how we can manipulate all those matrices and those distributions using NumPy, using little matplotlib and seaborn. So first of all, NumPy is the most important library you'll use throughout. Like if you do machine learning, deep learning, or data science, anything, NumPy is the first thing you'll import, and that's always. You will not be able to build any model, do any analysis without NumPy. Because for data analysis, for making models, you need to transform your data or resize your images or manipulate the matrices. That's the most important part, and all this can be done using NumPy only. So it's very important to understand NumPy, and it's very easy to. As compared to pandas and matplotlib, I find NumPy more easier. So first of all, throughout, if you get stuck or you want to explore more, the best resource is the documentation. You can go here at numpy.org and you can find all the information. This is the best place to learn. I find documentation to the best place to learn any new library or anything. So exit it. And then few days ago, I did a session on NumPy. So here's the link to the repo. So you can go here too. And I have covered some basic functions that will be useful throughout. So, okay, so let's start. So for using NumPy, first of all, you need to import that. And for importing that, you need NumPy to be installed. If you don't have NumPy installed in your workspace, you have to do that using this command. Pip install NumPy. But it's already installed, so it will tell me the requirement is fulfilled. Requirement already satisfied because I've already installed it. But for new users, if you don't have NumPy installed, first of all, you have to use this command to install it. And then when you have finally installed it, you can import it to use. And for importing NumPy, we have to use this keyword import and then write the name of the library NumPy. And as NumPy, I have written as NumPy. I've written as NumPy because I don't want to use NumPy again and again for referencing any function. For accessing functions, I'm going to use NP instead of writing NumPy again and again. So it's just a shortcut method. Then when you have imported NumPy, let's start with making a vector first. So here I'm declaring a Python list. Li is equal to list, and after declaring that list, I am going to make that a vector. So vector is equal to np.array. This function np.array is used to make the matrices. In this case, we have one-dimensional list, so I am referencing that matrix as vector, but this function typically is used to make the arrays or matrices. I use the terms arrays and matrices interchangeably, but that they are the same thing. So here np.array will make a vector out of my list li. So let's print it. And I have checked the type. What is the type of the vector? So it's telling me that it is something from NumPy class and it's ND array. ND means n-dimensional array. Here it's one-dimensional, so it's one-dimensional array and one-dimensional arrays are vectors. So I've used the name vector for this.
And just to interrupt really quickly here, one of the reasons why NumPy is so fundamental to everything else, why it's at the bottom of the stack, is this ND array. So this is the big deal about NumPy. ND arrays are, they took great measures to have ND arrays stored contiguous in memory so that they are more efficient with the memory in your computer, so that they're faster. Because as we go on with this, we're going to be crunching a lot of data, and it is intensive. And any kind of speed up that you can get by storing matrices efficiently helps that. And so it is the ND array data type that is the core, among other things, of the NumPy library. Anyway, go ahead.
Yeah. So is that clear? Is this function clear to you? Basically, it's just taking anything, list or something as input, and it's giving you the array. Earlier, it was list type, and now it's ND array. So moving further. Yeah, you can simply pass your list as arguments and get np.array as output. Let's do the same thing for getting multi-dimensional Python list. So Here is a multi-dimensional Python list. This is a 2D list, and we are going to convert this into a matrix. So using the same method, np.array, we are passing multi-dimensional list here, and let's print the matrix. So you can see the matrix is 2, 3, 4, 45, 56, and 57. And the class here is again n-dimensional array. And in this case, it will be 2-dimensional array because our list is 2-dimensional. But can you observe these 2 brackets? These represents that it's 2-dimensional. Earlier, we had 1 bracket here, which was telling us that it's 1-dimensional array, which is vector. But now we have 2 brackets, and that tells us that this is 2-dimensional array or matrix. So number of rows is equal to 2, and number of columns are also equal to 2.
So let's take a pause for a sec. If anyone who has a notebook open, why don't we try doing a couple more of these? So why don't you try doing one where the rows of the matrix are reversed? If anyone could do one of those really quick. Instead of 2, 3, 4, 45, 56, 57, do 45, 56, 57, and then 1, 2, 3, 4. I just wanted people to realize that it's straightforward. I won't say it's easy because it's kind of hard to wrap your head around these being multidimensional, but the outer brackets, designate the matrix, and then the inner ones are the rows in order. So it is as straightforward as figuring out what your rows want. What you want your rows to be, and it's always rows first, then columns.
Is everyone clear or have questions?
Yeah, because this can be a little bit confusing.
And it's better to learn it well. So whenever you keep going, you're gonna need to know this.
Yeah. All right, let's. It looks like Yoshiki, you have a another example of one. Yeah, you had a 4. Let's see. We had a 2D list, and then you have one here. It says we can create arrays directly too. Oh, without creating a list. Yeah.
Yeah, the next example is about creating matrices directly without creating list first.
Yep. Oh, do you want me to share, or do you want to share? I think you need to scroll down to where that cell is. Sorry. At least that's what I'm seeing on my screen. I can't see this cell.
Yeah, I'm just seeing NumPy, yeah.
Let me reshare then.
Yeah.
Okay now?
Ah, perfect. Yes. Now I'm seeing it. Great. Thank you.
Yes.
Yeah. So here's another example. In this case, we are not creating lists. Like here we created lists first before making the matrix, but now we are directly passing our list in here. So I am passing in 2-dimensional list, as you can see from this 2 brackets here. So this is 2-dimensional list. I'm passing it directly into the np.array function, and it will return us the matrix. So here it is, and you can check it type too. So it's again n-dimensional array. You can create these arrays by passing in 3-dimensional, 4-dimensional matrices too. That's up to you. That's why it's n-dimensional array, because you can pass any dimensional list here to make the array.
And if you if you have it print the shape, what does the shape say this is?
Sorry?
Shape, right?
Oh, shape.
Yeah.
4, 2. As you can see, we have 4 rows This is the first row, this is the second row, third and fourth, and two columns in each row. So the shape is 4, 2, and it's a pupil Gaussian error. If you do this, you will get an error because shape is an attribute and you cannot use these brackets to access it. So you have to remove these brackets and then access its shape. So let's check the shape here. Yeah, 2, 3, because you can see we have 2 rows and 3 columns. So our shape is 2, 3. And for the vector, let's check what the shape is. Print vector dot shape, and you can see it's 6 only because we have 6 elements. So this is a vector, but in case of vector 2, we have the number of rows and comma here. So this is the shape of our vector 6, comma. Nothing in this part shows that we have a vector.
And so what does a 3-dimensional array look like, just briefly? So if we add one more dimension to that second one?
Yeah.
Because that's where my brain starts to not work. Is instead of having 2 dimensions, if you have 3, how that looks in brackets.
Would it be easier if I show that using the random functions?
Sure. You could go ahead and do that.
Yeah.
Yeah, just keep in mind that the n of the ND array is for n dimensions, which is more than 3. It can be as many as it needs to be, and those are kind of stacked one on top of each other. But now I'll go ahead and let Yashika show you.
Okay, so before moving on to the random module, how to access elements of vector or matrix. If you want to access a particular element, you have to use indices like we use in Python list. So in case of a vector, what if we want to access element index number 2? So we have to use vector and square brackets and pass the element you want to access here. So vector and brackets 2. So let me comment this out. So we have 4 at index 2. And similarly, if you want something to access in a matrix, you are going to use 2 brackets, one for the row and another one for the column. And for 3-dimensional arrays, you have to use one additional square bracket for the depth, and we will see that later. So here in the matrix, what if I want to access element at row number 1 and column number 0? And keep in mind that the indexing starts from 0. So intuitively, it would look like I'm talking about row number 2 and column number 1, but it's actually row number 1 and column number 0. The matrix, yeah. So row number 1 and column number 0 would be this, 45. So 45, yes. And if I want to access, let's say, I want to check what is present at row number 0 and column number 2. So I should get 4. Let's see. Row number 0 and column number 2. Yeah, 4 it is. So is it clear? Any doubts? Shall we move further, or anyone wants to ask anything?
So Patricia has a question about reversing the array or the matrix. And I was just typing to her that this was not a mathematical reversal, so not in the linear algebra sense. We just put the second row first and the first row second. If we were actually fully transposing the matrix, it would look different than that, but we were just flipping the rows. So that wasn't a math thing, although Python can do that for you too. And so can NumPy. There are operations that you can call to transform matrices, but we just flipped the order of the rows.
Yeah, I've not actually reversed an NumPy array.
Yeah, and you know, and NumPy makes that easy to do. And if your matrices are symmetrical, you can also mathematically reverse or transform them, but we're not doing that today. Yeah.
Yeah. So should I start this random module now? Okay, let's start.
So Karen, sorry, I don't mean to interrupt you too much, but Karen has a different question about not the math relation, but to use a comma to concatenate two different data types together in print.
I don't think so.
Oh, I'm sorry, go ahead.
Yeah, say.
I was going to say plus is the way to concatenate strings, but what you're seeing Yashika do when she puts a comma in is that she's just listing out things. And so Python has this interesting, it's actually Python and not Jupyter, has this interesting trick. So if you put stuff inside of parentheses in a return or a print statement and you put a comma between things, Python assumes that you want all of that kind of put together on output. So there's this implicit concatenation that goes on. The plus, when you use it, can only be used to concatenate two strings together. But if you're in a return statement, you can actually put a comma in there and have a tuple returned, where Python will just concatenate the two things together. And so Yashika is taking a little bit advantage of that because she knows that Python is going to implicitly concatenate things inside that print statement. And so she uses a comma to kind of do that. Because if she was to use a plus for some of these, then she'd actually have to cast the type of the variable she's returning to a string. And she doesn't really want to do that, but she does want them to both appear on the same line. So that's where you're seeing the comma. Okay, sorry. Go ahead. Thank you for the question.
Yeah, someone is asking about the three-dimensional array, so I think I should do it right now.
Yeah, do you want to do a little demo of a three-dimensional array and kind of and maybe you can help my poor brain out, because I'm really good at slicing with 1 and 2 dimensions, but 3 dimensions, whew. My brain doesn't work so well with 3.
Okay, so it's now a 3D list. So can you point out the error, but please let me?
Let's see. So we've got 1, 2, 3, 4, 5, 6. Oh, for your final one, you need, I think you're missing 1 bracket to the left of the 5, 4, 5, right? You're trying to do a 3D? So 3 brackets. Yeah, you need 1 more. So the last row of your last frame to the left of the 5, 4, 5. Don't you need an additional bracket there?
Here.
Am I reading that correctly?
I think.
But then you need another row in that final.
Add another row with numbers. Add another row in there. Yeah, add the bracket and add another number as well.
Yeah, you need both the bracket and another row, right? So you need the bracket first.
So open the bracket in there, and then add 3 numbers more. Just right there, 3 numbers.
like here.
And then
This is the
close
reason
it.
I use random functions, because
And
the
then
3D.
you want to
Uh,
close the after the 96, you need to do another close bracket.
mhm.
I think
Okay.
that's right. That looks good now, I think. Yep.
Yeah. Thank you.
You're welcome.
So here's a three-dimensional list, and we can print that out using our np.array function. And then the matrix is finally this, and you can see three brackets here, and that tells us that this is n-dimensional array, and in this case this is three-dimensional array, and the shape is 3, 2, 3. So this means the number of rows is 3, number of columns 2, and the depth is 3. I don't usually use this way to use n-dimensional. I don't usually this way to create n-dimensional array, because I find random module is a better option to create these arrays, because you lose track of the number of brackets when you create these n-dimensional arrays manually. So that's the reason that we use NumPy, because it lets us create multi-dimensional arrays so easily. So is it clear?
And to mention too about an array like that, because it's too long, it's easy to get lost in the lines. So for practice, what I do, I put each line, like I put 2, 3, 4, 45, 56, 57, and then I close and I put a comma, and then the next line, and then the next line. I separate it per line, so that way you don't get confused. It's a little easier to read. When you're practicing, it's a little easier to read.
Yeah, because that's the way, I mean, that's a really smart thing to do, Liliana, because that's the way the library is giving it back to you when it prints it as well, probably for that very reason. And that's another, and then you can also tell at a glance whether or not your array is what's called ragged. So if your row length doesn't match for the whole matrix, you might have what's called a ragged array, which is where, you know, one line is longer. And that limits the kinds of operations you can do on it, because it's not symmetrical. And it's better that you know that at a glance than later when you try to do something to it. Yeah. A lot of, another trick you will see a lot of is where someone will put in the data as a 1 or 2 dimensional array, and then use the command reshape to shape the data, rather than risk making a mistake typing it in this way, because I'm a total fumble finger, so I tend to try to use reshape or something else, because I feel like the library is probably more trustworthy than I am. I am known for making typos, so yeah. Don, to answer your question, is it 2 columns or 3? This is also why you call shape, because then it's there in numbers for you, because your eyes lie. They always lie. It's kind of like you can't see your own typos, and in NumPy, you can never see the shape of something. You have to ask the library for it, or at least I have to. Yeah. So how does one slice that thing? I'm being mean. I shouldn't make you do that, Yoshika. It's okay. You don't have to slice it.
Okay, for slicing or accessing?
Doing a 3D one. So if you're slicing a 3D one and you want like a slice through all 3 dimensions, what does that look like? Let's do that if we can. So that one above, let's see.
I did not get your question.
So let's do a slice through those 3 layers, right? This is a 3D, so this is a tensor. So if we could just give someone an example, or give an example of, okay, maybe not a slice, but do, you know, like select
Yeah, I
78
was
out of
asking
it.
you that yeah, I was asking that are you asking me to do accessing in the three-dimensional matrix?
Okay.
Is that what is, yeah.
Yeah. So like
So,
Don said, return the 78. So what does it look like if you need to return the 78? Let's all work on that. What does that look like if we have to return the 78 from that first one?
Can anyone answer this? Drop down your answer in the chat box.
111.
Let us see what it will give us. 111.
Yeah, let's see what 111 gives us.
Yeah, 78.
Well, look at you, Dawn. I think we need to give something hard to Dawn so that she has to think, because she doesn't appear to be breaking a sweat here. No, I'm rusty. Right.
So should I start with random module now?
Yeah, let's move on to some random stuff. What do you think? Is everybody ready to move on, or do you have more questions, or does anyone have another challenge for Dawn? Who's rusty? She swears.
No, I'm rusty.
Okay, starting with the random module now.
Yeah,
So,
let's go ahead and do that.
So as we've seen above that, it's a lot of headache to create three-dimensional arrays manually, like first create a three-dimensional list and then create an array. It's a lot of headache. But with the help of random module, we can do that easily. And let's first check out these three main functions. So before that, for using these random functions, we have to use this random module. And for using the random module, we have to write np.random each time we want to use any of these functions. Like for example, if I am going to use randint function, I am going to use np.random.randint. So you have to write np.random each and every time you want to access any of these functions. So using the random module, we can create random integer arrays and also random floating point arrays. So the first function is randint. It takes in three values. The first one is low, the second one is high, and third one is size. So this will give you a random valued array filled with random integer values, starting from the low point you passed in, taking it up to the high, and the size here depicts what size of the array do you want in return. So for example, if I want a single value, a single random integer value, so I'm not going to pass size here. I'm just passing 2, this is my low value, and 10, this is my high value. Between 2 and 10, return me any random integer. So let me comment out this part and let's see. So I've now created single valued random integer. Yeah, so it's giving me 9. Every time you run this cell, you will get some new number because it's randomly generating it again and again. 4. Now run it again, you'll get some other answer. 4. Yeah, so it's randomly generating an integer number for you every time you run this cell. And what if I don't want a single value and I want an array instead? So in that case, I am going to pass the size as whatever the size of array I want to be outputted. So here, between 1 and 100, give me an array of shape 4, 5, and all the values should be random integer values. So let's see what it will print out. So yeah, the shape is 4, 5, and you can check that as well. Print rand integer 2 dot shape. So the shape is 4, 5, 4 rows and 2 columns. No, sorry, 4 rows and 5 columns. First row, second row, third row, fourth row, and first column, second column, third column, fourth column, and fifth column. And similarly, you can pass in the data type here. This is another argument you can pass, and this is not of a great use, but yes, you can pass your data type here. And this time I'm creating a 2, 2 array with random integer values. And likewise, you can access the elements here like we did above. For accessing 60, that is present at row number 0 and column number 1. So I'm going to do 0, 1. So it will give you 52. And yeah, for creating, yeah, that's the next part. So is this clear?
And it's so much easier. if you're just in here to play with data, that is so much easier than typing it in yourself. Like,
yeah,
infinitely easier. Yeah.
So the next function is rand n. So recall what we studied in the last session. We studied the normal distribution. So based on the normal distribution, the random function will return you floating point numbers. So random distribution was a distribution in which we had mean is equal to 0 and variance is equal to 1. It was a bell-shaped distribution in which the mean was 0, if you can recall that. So based on that distribution, let me see, yeah. So this is the normal distribution. In this distribution, the mean is 0 and the variance is 1. So based on this distribution, the random function gives us random values. So it picks up random values based on this distribution and gives you your array. So here, if you don't pass in the size, it's gonna give you a single value. And yeah, point to be noted here is, for the random function, you were passing low and high because you wanted values between this range. But since random function is totally based on the normal distribution, so you don't have to tell that what is the low and what is the high. It's automatically give you values based on the normal distribution. So you just have to pass the size. And that's an optional argument, because if you don't pass the size here, you will get a single value. So let's see. It will give you this value, and it's a random value. And also, if you don't use this dot random here, you will get an error, because this is a function present in the random module, so you have to use dot random as well. Module NumPy has no attribute random, so you have to always include dot random before using these functions. So okay, what if I don't want a single value and an array full of values? So in that case, I'm going to pass the size here. So 4, 5 is my size of the array. And yeah, here it is. An array filled with random floating point values based on the normal distribution. And the accessing is also similar to that of rand here as well. You can access elements like we did earlier, rand and 2, 0, 1. This is the value returned. And the last function is rand, and it's similar to rand n. The difference is it's not based on the normal distribution, it's based on the uniform distribution instead. So uniform distribution, if you can recall, was something in which we had rectangular boxes. So based on that distribution, the rand function will give you your random valued arrays. So here also you don't have to input the low and high. You just have to pass in the size here, and it will give you your array. Note that the values you will be getting is between 0 and 1, and this is the closed interval and this is the open interval. What this means is 0 is included and 1 is excluded. So you might get values excluding 1. So yeah, difference between random and rand is the array created using rand is filled with random samples from the uniform distribution over 0, 1. Whereas array we created using the random was filled with random values based on the normal distribution. So n here represents the normal distribution. So yeah, not passing in size here, it will give me a single value. This is it. And if you pass the size here, you'll get an array. All right, and the accessing is same here. So when to use what? Generally we use random function when we need random values but integer values. So I want a random valued integer, random valued array, but I want the values to be integer. I don't want floating point values. In that case, I'll be using random function. But if I want floating point values, but both positive and negative, the random numbers that are both positive and negative, in that case, I'll be using random because it's based on the normal distribution. So it will give me both negative and positive values. But if you only want the positive values, you are going to use the random function because as you can see, it only returns the positive values as based on the uniform distribution. So is that clear? Any doubts?
No, I just want to point out that NumPy is, sometimes it can feel like it's an impossible amount to memorize, and you shouldn't approach it that way. You should approach it as trying to look for what you need and gradually kind of building up a pattern and learning it as you go. This is only 2 examples of sampling, but you can actually do sampling like this across any of the distributions that NumPy supports, in addition to like sampling from your own data and doing all sorts of different things. And so there's a lot of really cool tools in there, you know, both with, you know, doing it at random, but also doing it from a distribution or doing it from your own data, so that you say if you need to test something that you want 25% of your data to be a testing set, you can ask NumPy to sample it in that way, but do it in a random fashion. So there's just a really rich tool set, but also don't be intimidated because sometimes it can feel like you're reading the dictionary, and don't approach the NumPy docs as if you have to memorize them, because that's not going to work. But yes, this is, to me, this is one of the most awesome features of NumPy, is that you can simply say, look, it needs to be the random distribution and I want X amount of values, and my, you know, I want the dimensionality to be 3D, you know, and off it goes. So it's very cool.
Okay. And from 3D, we can get 3-dimensional array here. Mm-hmm.
Nice, yeah.
Yeah, so 3-dimensional array, you can see 3 brackets and you can check your shape. rank in 3. No shape. So
Perfect.
it's a lot easier than what we did above using the list.
Yeah, this is a better way to keep your sanity. Clearly.
Yeah, and we will be revisiting NumPy again. The purpose of today's session was to deal with matrices, so we are keeping it concise, but we might revisit NumPy and use some extra functions as well. What do you think, Bethany?
Yeah, I think so, because I think there's a really rich set of tools here, and there's a lot, and that, you know, it bears repeating and revisiting. I know personally, Liliana and I both have done quite a bit with NumPy, but there's so much that you can use and play with, that revisiting it always helps, I think.
Yeah. So, doubts? You can ask questions.
Just let us know. And just to time keep briefly here, we did set this for an hour and 15 minutes, but we did get started a little bit late. So we have about 10 minutes, 15 tops left in this session. And if we don't get to all of this, we are going to pause until January, but we can revisit this specific set of notebooks, or we can also just revisit these topics, and we'll be revisiting these topics in subsequent sessions. So don't worry if you have to drop, or also if we don't get to the end of this, because you can ask follow-up questions in the Slack channel. Ping Yashika or myself or Liliana with questions, and we'll be going back over this as well. Yes, we are recording this session, and we do post them. It is volunteer work, so we may not be posting them quickly, but they will be posted to our YouTube channel. All right.
Okay, so on to the distributions now. For visualizing these distributions, I'm using matplotlib and seaborn, because for plotting you'll need both of them. I could have used only matplotlib, but for more interactive visualizations, I'm using seaborn too, because seaborn is more interactive and attractive, if I say.
Better colors, better charts. And also a little bit, I don't know if you find this, Jessica, I find Seaborn a little bit more performant as well. Matplotlib is kind of starting to show its age a little bit.
Yeah. So here are some resources you can visit. These are for histograms, and if you don't know what histograms are, you can visit here and read a bit.
Yep.
So first of all, what we will be doing is we will visualize what normal distribution looks like using NumPy and Matplotlib. So normal distribution, also known as Gaussian distribution. So as I told above, in normal distribution, we have mean equal to 0 and variance equal to 1. So first of all, for using Matplotlib, again, if you have not installed it, you have to install it first using pip install. But I have already installed it, so I'm just going to use import to use that library. So this is a magic function. You can ignore it, and we are using import here for using this library. So import matplotlib.pyplot as plt. So similar to np, we are using plt for not writing matplotlib.pyplot again and again. So importing it as PLT here, and these two lines will just, the first line will just make pretty matplotlib plots, and the second will just pick some figure size. So you can ignore that for now. So this is a function we haven't talked about, linspace. This is a part of the NumPy library. This linspace is something similar to random integer, but in this case, it will give us linearly spaced integers. So if I want values between -5 and 5, but linearly spaced values, so I'm going to use linspace in this case. Linearly spaced means the step we are taking from going one element to another, we are taking a fixed step size. So in that case, we use linspace. We will do this later when we will revisit NumPy. So setting mean is equal to 0 and variance is equal to 1 here. So this is the very daunting formula we have for PDF of normal distribution. You could either use this formula to see how it looks like, but just let us, yeah, PLT is not defined. Okay, I didn't import, I didn't run this cell. Here. So this is the normal distribution. We have plotted using this scary function, but you can just use np.normal instead. It will work similarly. So using np.random.normal function, we can plot this same normal distribution graph. But this time I'm not using matplotlib, this time I'll be using Seaborn. So using first using Seaborn, first of all you have to install it, and after you install it you are using import Seaborn as SNS. This you can write anything here, you can write SB, SN, anything you want. It's just a practice to use SNS. So I'm importing Seaborn as SNS, and then I'm creating I'm using normally distributed values, and then I could have plotted it using the histogram plot using plot.hist. This is the function provided by the matplotlib, but instead I'm using SNS distplot. This works similar like matplotlib's histogram. So let me run this cell. Yeah, and the difference is if you use matplotlib's histogram, you will not get this overlaid curve above. So that's why Seaborn is much prettier and interactive. So PLT title would just set the title for a graph, normal distribution in this case. X label sets the label for your x-axis, and PLT.y label sets the label for your y-axis. So yeah, the purpose of using this function is just to show you how a normal distribution would look like using Seaborn or matplotlib along with NumPy. Similarly, we can use np.random.uniform function to see how a uniform distribution would look like. We are not going to use the PDF and scary formulas here. We are just going to use np.random module for plotting this uniform distribution. So I've just run this first. Yeah, so this definitely doesn't look like a uniform distribution because I have used matplotlib, and now when I use Seaborn's distplot, you can see a uniform distribution like shape here. It's a rectangular box, and you can see the uniform distribution here. Again, setting the title, label, and plt.show is just for the sake of showing that plot. If you don't use plt.show, that it will give you some additional information about the plot. So I don't want that, so I'll use plt.show. So it will not give me anything before plotting. Yeah. So the third distribution is Bernoulli distribution, which was a case of binomial distribution as we discussed, where we only conduct a single experiment. And recall it's a discrete probability distribution. And here P was for success. If we have successful event or yes, true or one, we have P, and for Q, Q is equal to 1 minus P because probability, the sum in the probability is always 1. So if we have to calculate Q, we need to do 1 minus P. So you can go to the resource and dive deeper in binomial distribution. So for the next plot, Bernoulli distribution, since Bernoulli is a binomial distribution, so I am using NP.random binomial. So here I'm going to print out this. Yeah, so this is something Bernoulli distribution would look like. I know this is very confusing right now and it's not very intuitive, but when we will actually start using actual functions and then when we use these distributions and functions, it would be more interactive and it would be more understanding maybe. The next distribution is binomial distribution. So using same function np.random.binomial, we are going to plot the binomial distribution, and it's more intuitive than I was looking like. The last one is the Poisson's distribution, and which is used for large n values. So in this case, I'm using 1000 values. So again, using Seaborn's list plot function and all the labels and titles. Yeah. And lastly, if you want to plot some equations, so let me quickly just go through it. If you want to plot some equations, and that is much easier than plotting these distributions. For plotting the equations, I'm first taking x as np.linspace. It will give me 50 linearly spaced values between 1 and 100, and then I'm making my y function as x square, x to the power 2, and then I'm using matplotlib to plot these two x and y. So plot x comma y, and v is just here for the shape. Like let me run this first. So it's type of inverted triangle you can see here. But if I use dot in case of or O in case of v, the output will look something like this. So I just made x as linearly spaced value and y, I squared x for y, and I just plotted the two. And then if you want to plot a sinusoidal or cosine wave, you can use np.sine or np.cosine function. And a range is another function present in NumPy, and this will just give 10 values, and then I'm going to plot this, and you can see the sine wave. I could have used cosine wave too. And then this cell would just let you see how we can plot different functions in the same, different equations in the same plot.
I use this exact thing oftentimes to do things like if any of you have done big O analysis of stuff, I always have to get into pandas and do myself a plot of what those things look like. Like what does big O of n squared look like? Because I can't ever keep them straight. So I always do graphs like these where you do multiple lines on the same graph so that I can. But Yeah, the legend is really cool. Sorry.
Yeah, so that's all.
For me, graphing is a push-pull thing. I can sometimes get sucked into a black hole and graph all the things because I like making pretty pictures. And I get distracted, and then I don't do anything else but make pictures all afternoon. But it's kind of fun. It's kind of fun to play around with this stuff. And it helps me, at least personally, to visualize algorithms and distributions. So, Ishika, thank you. This has been excellent. Does anyone have any questions for Ishika before we wrap? We have about 3 minutes, and then we should let all of you go, because for some of you, I know it's getting quite late. Well, if you do think of questions, we are available in the Slack channel, and we do have another session that's shifted for a different time zone that's going to happen next Monday. It's going to be the same material, but different host. If you want to attend that one is actually at 7 p.m. Central European time / West Africa time. So there's another chance there to review this material. Yeah, thank you all for attending. I actually have a little end of session thing. So thank you for attending. And if you want to get involved and help us grow, we're always looking for leads and evangelists. You can go to womanwhocode.com/Python if you'd like to get involved. And if you'd like to join the conversation, we've got Instagram if you scan the QR code, we've got Twitter, we've got our Slack channel, and we've got our website. So thank you again, and thank you so much, Ishika, for hosting and for putting together this awesome material.
Thank you so much, and thank you so much everyone for attending, and I hope this was beneficial for you.
Oh, and
no, it's not Yashmak, it's Yashika. Until unless you heard my name wrong. Yeah.
Oh, yeah. I lisp, so I apologize. It's probably my fault. And the other thing I wanted to say is, Dawn, so no more new ML content until 2020 for a couple reasons. One is that we do have a lot of people who are from regions that are celebrating the Christmas holiday. So we kind of know that that gets very busy for people, but also Yashika is fielding finals and internship requests, and so we also want to give her a little bit of a break because she is a very busy, popular woman, and do a little planning. So yes, we are going to reconvene on the 6th of January, but we are available in Slack for impromptu discussions and fielding questions and all of that sort of stuff. All right, well, thank you very much, everyone, for attending. Again, we're Women Who Code Python, and hit us up if you want a Slack invite. And yeah, keep the conversation going, help each other. Plan some robots, take over the world.